Good afternoon, everyone. My paper ID is 114. My name is Mohsin Hassan, and my paper title is Neural Network Based Obfuscated Malware Detection. The outline of my paper is what is a malware, various types of malware. The important malware is an obfuscated malware, anti-virus techniques. That is how they detect the antiviruses, specifically malwares, and artificial neural networks, my experimental setups, the results, and the conclusion. We have seen that today's everywhere we are using electronics, mobile phones, pen drives, Fitbits, and everything, and there we have huge amount of data, and that's why there are illegit people who are working to get our data. So the malware definition has three important words. It's illegal action, it's not intended by the users, and it's reveal information or harm data or a computer. So these are the three main characteristics which every malware has. Every program which is influenced by the virus, it's doing some specific activity on what information maker wanted instead of having a particular feature. So you go on various sites, you download the softwares unintendedly, and in that, instead of a specific features, they are having the illegit software. And malware attacks are growing day by day. You can have a white paper of semantic where you can have the statistics that how the number of viruses are growing day by day. Types of malwares are various. The first one is a virus, worms, Trojans, spywares, adware. Recently there is ransomwares, botnets, polymorphic viruses, and obfuscated viruses. The virus is the application which is not working independently. It needs some host, and it's attached with that host, and then it creates an environment, and it spy your data or deletes your data or modify your data. So the virus is typically different from worms is in the sense that worms is independent, while the virus has an attached legitimate application, and it attach it. The Trojan is the specific software which is created based on the concept of Trojan horse, meaning it's not carrying any deadliest code, but it goes into the system and then it opens the door so that the powerful applications can later be downloaded by the attackers. So typically the Trojan horse gives an environment for the attackers to further attack the systems. Spyware is a software which spies on your data, and it's apart from the virus and worms, spyware it's difficult to detect because it's not modifying the system performance at all. It just sits silently and monitors your data. At a specific time it sends this data to the specific machine. Adwares are a software which monitors your activity, specifically your shopping activities, where you visit, internet, and then this data it sends so that further advertisement can be done, and this data is sent to some of the advertisement companies. Recently a new trend is coming which is called a ransomware. What it does is that when it comes into your system, it copies the data, it encrypts the data usually, and then it displays a message that if you want your data back in so and so date, then you pay us some money on specific account. So what it does is that it encrypts entire file system, and unless you don't pay them money, they don't give you a key, and so your data is encrypted, and if it's having important data, you have to pay them money, and that's why it's called ransom. Botnets are the zombie machines which is created by some organizations, and this organizations has millions of machines across the internet, sleeping mode, and when they say that the machine should be attacked, XYZ machine should be attacked, so this all machine will come from the zombie mode to an active mode and attack, and that's why the botnets are specifically used in DDoS attacks. And the last two categories is polymorphic and obfuscated malware. These two are the techniques, and this can be used in all of the above viruses. So virus can be a polymorphic virus, Trojan can be obfuscated Trojan, obfuscated spyware can also be there. Now, what is an obfuscated malware? So they are different from the typical malware is that they change their structure. So internal structure will change, so its appearance is changed, and so its signature is changed. So all the antivirus which are using signature based architecture will not be able to detect it, because one malware, when it goes into another environment, it changes structure. How it changes structure is below, way to change the signature. So instruction substitution, date code insertion. So instead of specific instruction add, it uses addx or some other instructions. So multiplying, and then this instruction is changed, so the signature will change. Similarly, it adds few unnecessary date codes, instructions permutations, changing the flow of the structure, and variable substitution. So using this 5 basic techniques, the program structure internally changes and overall signature change of the malware. So one specific malware will have thousands of signatures. So for malware mutation, how the malware mutation does is that with the actual code they attach the decryption engine, and this decryption engine creates mutation virus, and that's why it has thousands of malwares. How the state of art antivirus detection works is techniques is signature based. As I said, that signature based is based on the binary footprint of any signature. So a file has a specific strings of bits, and based on that it generates a fingerprint, and the fingerprint is unique for each typical malware. But when you say it's an obfuscated malware, one obfuscated malware may have thousands of signatures. So to detect it, you need all their signatures. Second technique is system change detection techniques. This technique is used as sub-functionality in most of the antivirus. It monitors that what the file system is and the folders, and this is achieved by generating a hash of a file. So later this hash is compared with an original file hash, and if there is a change, it will say that it's a malware, and that's why using this, lot of false alarm will be generated. Because let's say you have an office and then you update it. So as soon as you update it, the hash will change, and the hash which antivirus has is different, and then it will say that this is the thread alarm, but it's a legitimate application. So that's why this state system change detection is usually put in sub-functionality. Heuristic is it checks an alarm detection in file execution and code emulation. My approach was to detect this obfuscated malware using artificial neural network. So I'm just giving a brief introduction what an artificial neural network is. The AN is simulated as the human brain. It deciphers information determining the latest knowledge of psychology, biology, and physiology. Artificial neural networks specifically used in pattern recognition and pattern matching, and we are using a pattern matching mechanism. And pattern recognition is a method in which unknown patterns are recognized by comparing it with its various patterns. So what we are going to do is that our obfuscated malwares has few hundred patterns, and this pattern will be given to neural network, and it will try to learn that when the new virus comes of the same family, then it will identify that okay, this is the pattern of this, so you don't need hundreds of signatures, but you need few patterns, and from that it will identify the next patterns. My experimental setup consists of generating many signatures, and for that specifically NGVC toolkit is available. It takes an input of a malware and it generates hundreds of metamorphic viruses. Now these metamorphic viruses are COM structures, so we need to convert it into assembly. So for that we are using TASM. Once this TASM assembly based files are generated, we are using C# code to generate an instruction sets, and this instruction sets means for a specific malware you will have 50 files. For each of these files you will have an instruction set, and this is passed to ANN. Once the ANN learns this using training data, we pass it a testing data of few other malware signatures, and then it identifies the patterns. So these are our statistics. We have a train size of virus This is 200 files and non-virus 80 files. Why this is 200 is because we have different patterns of a same virus. So when we keep a neural network to 5, you can see the miss rate is getting high somewhere. Initially it goes low and then it goes again high and then low. So when we have more neurons in the neural networks, we have less false alarm and we have false positive also. Similarly, this is the typical other data, and finally we have a conclusion that my study indicates that when you have a huge nowadays this metamorphic virus is a new trend, so you need an engine which generates more of such patterns, and second is using ANN, you can produce a false positive alarm. Thank you very much.